everyone. My name is Sarah Struthers, and I am a second-year PhD student at the University of Edinburgh in Scotland's Royal College. And I'm technically not part of a Canadian institution at present, but I thought I would show some of the research that Canadians are doing abroad. And so I'm going to be giving an overview of my PhD project today, which is entitled Using Pre-Existing Variation in Beak Morphology to Reduce Pecking Damage in Laying Hens. And so beak shape differs between different bird species because each species has evolved a specific shape to fit both their diet and environment. And chickens appear to have the perfect beak shape to grasp and pull feathers and body tissue, and this can lead to serious welfare concerns such as severe feather pecking and cannibalism. And previous research has focused on genetic selection against severe feather pecking, but a challenge is that it can be difficult to collect and quantify meaningful behavior data that can then be implemented into a breeding program. And the solution to this may be to select for traits that are related to severe feather pecking but are easier to measure. And examples of these traits include livability, plumage cover, and beak shape. So substantial variation in beak shape exists within non-beak treated laying hen flocks, and beak shape appears to be heritable. And so the question that serves as the basis of my PhD project is, can we take advantage of this pre-existing variation and identify beak shapes that cause the least damage when birds engage in severe feather pecking? And then from there, can we identify quantitative trait loci that are responsible for this variation? So to identify these different beak phenotypes, I am using geometric morphometrics, or GMM, which is the analysis of shape using landmark coordinates. And so there are 3 steps to GMM. The first is to collect landmark coordinate data, and then these landmark coordinates then undergo Procrustes superimposition. And finally, the third step is to analyze the similarities and differences in shape, and this can be done using principal components analysis. And GMM is typically applied to dead specimens, but if it is done using live specimens, the method of image acquisition is typically photography. So the 4 objectives of my PhD are to 1, identify different pre-existing beak shapes, 2, identify QTL that may underlie beak shape, 3rd is to determine which beak shape is optimal for reducing injuries related to severe feather pecking, and 4th is to investigate differences in feather pecking damage between hens that have different beak shapes. So the first study that I conducted was a repeatability study to generate data on the use of radiography to measure beak shape. And so as I mentioned before, GMM is typically applied to dead specimens, or if using live specimens, applied to photographs. And to my knowledge, GMM has not been applied to radiographs for the assessment and characterization of beak shape in poultry. And so this study helped develop the novel capability of using radiography for the application of GMM in live non-sedated laying hens. And so this study aimed to answer if the process of imaging these hens and then landmarking those images is repeatable and reliable. So it was conducted at the National Avian Research Facility at Roslin Institute and used 24 advanced intercross line, or AIL, hens that were radiographed 4 times each. So to collect the data for my PhD project, I used a portable X-ray device, which is shown on the left. And to reduce the bird handler's exposure to radiation, I custom designed restraint devices to hold the hens in place. So a restraint jacket that was made out of cotton denim is shown in the top right picture, and then for immobilizing the head, a cotton hood was designed, and it's shown in the bottom left picture. And so from my repeatability study, I found that yes, landmarking the images was repeatable and that the highest source of variation was coming from the bird. And so this led to my second study, which was conducted on a pedigree layer farm. So the objective was to image pure line hens in order to generate beak morphometric data and then describe the variation in beak and bone shape. And I also wanted to compare plumage cover to different beak measurements, and so I used 2 different white leghorn pure lines. So data collected included radiographs, photographs, plumage cover, beak overhang length, which is shown in the bottom picture, and mortality. And then blood was also collected for genotyping. So the radiograph analysis that I have completed so far is of the premaxillary and dentary bones within the top and bottom beak respectively. And so each radiograph was landmarked in ImageJ and then analyzed using the R package geomorph. And I'm actually going to be presenting the results of this analysis at PSA this year, and then we'll soon be publishing this data in Poultry Science. So to finish, the next steps of my project are to analyze the external beak shape. Second is to complete the QTL analysis. And finally, I'm going to be investigating the relationship between these different beak shapes and severe feather pecking behavior. Thank you for listening.
Oh, thank you very much for a great presentation, and welcome on the Canadian side. Must be getting a little late there in Scotland.
It is. Well, it's 6 o'clock, so not too late. But
okay, not bad. So the great presentation, and I'm kind of intrigued by a little bit the design. So the strait jacket and the hood, they do not interfere with X-rays, or?
No, they're completely radiolucent. So everything, you can see everything through the hood.
Oh, well, thank you very much. That's really nice. That would probably work with a DEXA scanning or MRI scanner as well.
Yeah, I think so. And it was quite easy to make. So I just cut up a pair of old jeans and bought cotton fabric. So they're not expensive and quite easy to make.
All right. So from your study now, what would you recommend in terms of beak trimming, which is kind of still a big welfare issue?
Yes. So I think with the movement away from beak treatment, that's one of the goals of this project, is to see if we can potentially house commercial non-beak treated laying hens. So I think right now there really isn't a reliable alternative that compares as well as beak treatment. But hopefully my project will help provide data that shows maybe if the breeding companies do start selecting for beak shape or for these blunter beak shapes, maybe in the future beak treatment can be eliminated. But I think as of right now, it's still the most reliable method of reducing the damage from severe feather pecking.
All right, thank you very much. Here I see there is the question from Tina. How many strains will you be tackling? How does variation, I see, oh, I saw it. Oh, it's in the message. How does variation within and across strain compares?
So we're not going to be using different feather colors, but we are going to be using two lines, pure lines, that contribute to the four-way hybrid commercial layers. So we'll have two lines to compare. And then as of right now, there does seem to be quite a bit of variation between the lines, at least for the analysis that I've done so far, which is of the bone shape. There does seem to be some separation between the lines, which is really interesting. And then that's actually the data that I'll be presenting next month at PSA, and then hopefully publishing soon.
All right, thank you very much.